All right, we're going back and doing 11.2 because, again, 11.3 we did yesterday, and I just kind of, it was a mistake. So we're going back to 11.2. It's okay because you didn't have to know 11.2 to do 11.3, so it's no big deal. It doesn't really matter what order we do this in. What do I have right here? What is this figure called? Well, it is quadrilateral, it's true, but get a little more specific. Let's say that this side is parallel to this side. It's not a parallelogram, because a parallelogram, both pairs of opposite sides are parallel. But on this one, that and that are definitely not parallel to each other. We have another name for it. We had a chapter, and we had one section out of that chapter was about this thing right here. Nobody remembers the name of that? Starts with a T.
Trapezoid.
It's a trapezoid. Okay. So watch this. I just want you to see there's a trapezoid is kind of close to something else, and something else that starts with a T. Watch, if I took this side right here, and then let's say I extended that side up a little bit like this. Let's say I took this side and I extended this side up to about right there. And let's get this one to get even with that. Alright, so Blake, what is this? We took a trapezoid, just by extending a couple sides, we turned it into a what? To a triangle. Okay, so a trapezoid actually has a relationship, you know, a little bit of a relationship with a trapezoid. Kind of looks like it. It's kind of like a triangle. A trapezoid is kind of like a triangle, but we chop the top off of it, right? So if I took a hatchet or something, right, and I sliced it right here, and if that was parallel to this, then I've got myself a trapezoid. So all I wanted you to do is see that, yeah, there's a distant relationship, okay, between a trapezoid and a triangle. And that's going to help you out with what we're going to do right now. It's going to help you out finding the area of the trapezoid. Because the area of a trapezoid is very, very close to the area of a triangle. So what is the area of a triangle, just as review? That's right. Okay. Alright, so let's write this down. So the area of a triangle is 1/2 the base times the height. But look at a trapezoid. A trapezoid doesn't just have one base. If you look at it, and we talked about this, we talked when we were in whatever, I forget the number of the chapter we were in, but it was about quadrilaterals, and we talked about the non-parallel sides, and we called those the legs of the trapezoid. So that was a leg and this was a leg. What did we call this and this? If these two were legs, we called these the bases. That's right. So we called this a base, and we called this a base. So unlike a triangle, which just has one base, everybody listening?
Yes.
Unlike a triangle that has one base, a trapezoid has how many? It's got two bases, okay? So let's call this base 1 and let's call this base 2. Everybody with me on that? So let's think about what the possible formula for the area of a trapezoid would be. So this is now the area of a trapezoid. Let's write that down. Area of a trapezoid. Alright, so watch. It's very, very close to the area of a triangle. In fact, trapezoid and triangle start with the same letter. In fact, they have the first two letters the same, don't they? Alright, so you can think of that. When you try to think of, oh, what was the area of a trapezoid? What did he say? Oh, yeah. They start with the same letter, you know, TR. And so it's really, really close to the area of a triangle. You should know the area of a triangle, 1/2 the base times the height. Well, the area of a trapezoid is really, really close to it. It's not just 1/2 the base times the height. How many bases do we have?
2.
We have 2 of them. So what do you think you might do to those two bases?
1/2 base 1 times base 2.
Well, we're not going to times them together. That's a good idea, but we're going to add them together. All right? So if I just take the two bases and add them together, that's like just saying the base of the triangle. You with me? So it's like one big old base. All right? So if I add them together, times what? Times the height. And there it is. It's really very, very close to the area of just a regular triangle. Except a triangle has one base and a trapezoid has how many? 2 bases. What do you do with those 2 bases? Just add them up. And if you can remember that, you can remember the area of a trapezoid. I think it's a nice, easy way to remember it. So think of that similarity, again, between a trapezoid and a triangle, and you can remember the area of a trapezoid. The hardest part about doing this chapter is just memorizing the different formulas for these different figures. All right, but it's up to you. You're going to have to take some time, put some effort into it, and remember the formulas for each of these. I have kids every year, so are you going to put all the formulas on the test? No, I'm not. It's your responsibility to learn these formulas. Okay? I'm telling you right now. So don't show up on the test and say, Mr. Hamburg, I can't believe you didn't put the formulas on there. It's not fair. Well, it is fair, because I'm telling you right now, a long time before we take a test on this, that you have to memorize the formulas. If you think about it, they haven't been real hard anyway. Area of the triangle was one of the formulas. What was the other one? Yeah, the area of a what? Yeah, but more generally, a parallelogram. Okay? The area of a parallelogram is what? Just the base times the height. Then we did circle yesterday. It's actually 11.3, but it's pi r squared. And really, that's it. Now we got area of a trapezoid. Those aren't hard. You learn this back when you're a kid. You learn this back when you're a kid. Same thing with this one, right? That should be all review. You may not have learned the area of a trapezoid before. This may be new to you. But it's really not that hard. It's really, really close to the area of a triangle. Everybody got that? So that's the area of a trapezoid. Let's put some other stuff in here. Now, when I say 1/2 the 2 bases times the height, I don't even have the height drawn here at all, do I? Let's draw in where the height would be. The height would be about right there. Now, I could have taken any point up here on this base as long as it was what to the other base?
Perpendicular.
Perpendicular. Everybody see this? So if I take it from the top, and usually they take it from one of these corners, one of these vertices, okay, from a vertex, and then down to the other base. That's where they normally would take it. So you make a triangle out of it and all that kind of thing, all right? But they could have taken it right here. As long as they're perpendicular to both of those, that's fine. And notice that height is perpendicular to not just this base, but to this base as well. Everybody see that? Yes? Okay, it's perpendicular to both bases. Alrighty, that's area of a trapezoid. So that would be the height. Let's put an H in there. Let's do a quick example on how we're going to do this. We'll do one that's about as easy as you could possibly get. Then we'll do another one that you have to think just a little bit more, but it's really not much more difficult. Alright, here's an example on how we're going to use that formula to find the area of this thing. It's actually pretty simple. It doesn't really get much easier than this. They give you everything in the formula that you need to know to find the area. There's no algebra involved. There's no, substituting this number in for that. It's just really, really basic. You got to know the area of a trapezoid, though. What I would do, here's a good hint for you. If you want to learn this stuff and you want to really have these formulas memorized, an easy way to do it is every time you have a problem where you're going to use one of these formulas, I would write that formula down. Okay, I would not just write the formula at the top of the paper and just refer back to that every single time. All right, you could do that. That would be easy. You write it once, that's all you have to write it. But that's not going to help you memorize it very well. If you write it down over and over and over again, every single time you're doing one of these problems, write down the formula, you're going to remember the formulas a lot easier. Okay, it's a good hint for you. Try to do that. So, what is the area of a trapezoid? We just talked about it. It's 1/2 what? Yep, base 1 plus base 2, right? Just add the two bases together times the height. Now look at this. This couldn't be easier because they give you everything you need to know, don't they? To find the area. So you got a 1/2. You take the two bases and you add them up. Now look, you might be able to just do that in your head. You might be able to put all those numbers in your calculator all in one shot. But what do I always ask you on your homeworks? To show what? Show your work. This is what I mean by showing your work. It's not necessarily a whole lot to show. It's just a matter of showing what you're putting into your formula. You could call either one of these B1 or B2, so I'll put 16 plus what? 6 times the height, which is 12. There you go. I showed my work. At this point, if you just want to put that into calculator, that's fine with me. But at least I saw that you knew to put those numbers where they're supposed to go. Everybody understand that? So I don't want to see like number 2, 37.5, and that's your answer. Okay, I don't want to just see this. That's not acceptable. I want to see this. Write down the formula, write down the numbers you plugged in, and then if you want to put that into a calculator, you can at this point. But I can do this a little easier. Watch this. What's 16 plus 6? You do that in your head, can't you? 22, right? Because that's 12, carry the 1, 22. And then that would be times 12. Look, without a calculator, what's half of 22? That's 11, isn't it? And what's 11 times 12? You should have that memorized. That's a multiplication table. 132. Anybody? I don't know too many tricks. There's some teachers that know all these tricks, how to do things in your head. I don't know a ton of them, but here's one that I know. It's kind of cool. Multiplying by 11. Did you ever see this? If you multiply by 11, a two-digit number anyway, multiply by 11, just like if you're multiplying 12 by 11, take the 1 and the 2, you split them up, add the two digits together, stick it in the middle, and that's how you multiply by 11. Isn't that kind of cool? Like 54 times 11. What would that be? You take the 5 and the 4, you split them up, and then what do you do to those? Add them up, stick them in the middle. There you go. That's 54 times 11. That's kind of cool, isn't it? All right. Now sometimes it gets a little bit. Sure it is. Sometimes it's a little bit tougher. If I had like 75 times 11, that takes a little bit of extra thought. What do? You split them up. But what's the problem though? It's 12, isn't it? So I'm not going to put a 1, 2. It's not going to be 7,000, isn't it? Is it? What do you think I'm going to do though? I'm going to put a 1 here and a 2 here, right? And so what is it? 825. Anyway, I just thought since I had the 11 there. Alright, whatever. You can say you just use a calculator. I'm just showing you a little trick. Okay. I don't know. Somebody showed me that somewhere in my life. I don't know. Okay. I don't know too many of those tricks. I mean, there's a bunch of tricks out there like that. In fact, I bought a book years ago. I don't think I ever read it. I might have looked at maybe one chapter in the book that has all these different tricks. And you think, oh, all you got to do is read the book. You know all these tricks. But a lot of these tricks, you know what? It might be just as easy just to do the multiplication than to know the tricks. Because sometimes I forget the tricks, but I know how to do the regular multiplication. But anyway, I thought I'd just throw that out there since I saw that 11 right there. I just thought that was kind of interesting. Okay. And that's how you find the area. It's pretty simple. Let's do another one where it's not quite as easy. It's the same formula. It's not quite as easy. They give you different stuff. So let's do this one. Okay, here's another trapezoid. I just stretched it out just to make it look a little different. It's not much different, but it's a trapezoid. You guys are watching, right? Hopefully you're writing this stuff down. You should be writing this stuff down. Can you find the area with this information? No, what are you missing? You're missing the height. But that's what they want you to find. So they got to tell you something else, right? In fact, they do. They tell you the area of this thing is 78. All right? Centimeters squared. And these are all centimeters. I'll just put that right there. So they do tell you the area. Now, if they just told you those first things I had written down, you wouldn't be able to find the area because you don't know the height. But they do tell you the area, and you have to find the height. In fact, if you don't like X, you can put, what? H for height. Maybe some people would rather see the H there because that's what's in our formula. Come on, touch. There you go. All right, so what are we going to do? Well, let's write down the formula. It's a trapezoid problem, so every time you do a trapezoid problem, I would write down the formula for trapezoid so that you remember it. It's 1/2 base plus base, right, times the height. Everybody got that? So you just add up the two bases, and it's 1/2 the base times the height once I add up the two bases. Now, what's the thing that I'm trying to find, though? I'm trying to find the height, aren't I?
Start it like you're doing the equation and divide the area.
Yeah, well, let's plug the stuff in. Okay, let's plug everything into this equation just like I did the other time. All right, but this time I don't have the area by itself. Now I know what the area is. So what do I put in for that? 78 equals what? 1/2. Now, let's put the two things in here. 6.4 plus 13 times what? H. And you could have made that an X if you wanted to. It doesn't make any difference. Javon, you getting all this? So 78 equals, watch, 1/2. We can do this in our head. What's 6 and 13? 19 what? 0.4, right? You can do that. And then times what? H. I don't really need that in parentheses, do I? There's a couple ways you could approach this. This is how I did it in the other class. I took 1/2 of 19.4. So I went 19.4 divided by 2. And I got 9.7. So let's write that down. So what I say was 9.7. 9.7 what? H. Right? 1/2 of 19.4. Everybody see that? And then it's to divide by 9.7. Exactly right. Divide that by 9.7. And then So what is it? 78 divided by 9.7, and it's 8.04, but just 8.0, right? So h is 8.0. It's a centimeters right here because that area was centimeters squared, and that's the height right there. It's 8. That's how tall that thing is. So it was a little bit more difficult. You had to do a little bit of algebra, didn't you? Get h by itself, but still it was plug and chug, right? You still plug the numbers in. You plugged in a 78, right? You plugged in the two bases, but then you had to work out some algebra. You had to do a little bit of algebra, which wasn't all that difficult. Basic, normal algebra 1 kind of stuff, and then you've got the height. So it was a little bit more difficult, but it's the same process. That's the area of a trapezoid. We good with that? All right. So we're going to learn actually formulas for 3 different pictures today. That was our first one, the trapezoid. But the nice thing is the next 2 pictures that we're going to look at have the same exact formula. So really we're only using 2 formulas, but 3 different shapes. All right. And let me grab, I got one of these shapes over here. Which one am I going to do? Let's do this one. I said we're going to, at the beginning of class, I said if we have enough time after I do the lesson, we'll go over the homework. All right, let's scooch down to here. All right, look at this thing. We talked about this a long time ago. This is a kite. Very good. All right, this is a kite. There's a couple things we know about the kite. These are the diagonals of the kite. They intersect each other perpendicular. Okay, so they make a right triangle right here. We learned that a long time ago when we learned that chapter on quadrilaterals. We know that this side and this side are equal to each other. We know this side and this side are equal to each other. We know that only one pair of opposite angles are equal. So these 2 right here are the opposite, equal opposite angles. This one right here is skinnier than this one. Do you see that? So those 2 angles are not equal to each other. So we know stuff about a kite. The 2 triangles are congruent to each other. There's all that kind of stuff. But I don't really care about all that stuff. Actually, let's just do this. I don't care about all that stuff today. What I care about is finding the area of this kite. So finding the area of the kite. Okay? What's that? It's not a trapezoid because a trapezoid has one pair, or they have exactly one pair of parallel sides. None of these sides are parallel to each other. Okay, that is not parallel to this. This is not parallel to that. So it's not a parallelogram, and it's also not a trapezoid, is it? That's why it's got a special name, and that's why we call it a kite. Everybody got that? Now what I want to do is this. I'm going to make these different colors. We'll ungroup this, and I'll select this one. I'll make it a different color. Let's make it this pink color right here, and let's talk about this one right here and make this, I don't know, yellow. All right. What are those 2 things? I already said the word already. What are they? They're diagonals. Okay. So here's the formula of a kite. It's actually pretty easy. It's very, very similar to the to a triangle. If you want to think of it, see this pink one? Think of that as your base, and think of this yellow one as your height. It's not exactly a base and a height. Don't call it base and height, but it's kind of like it. The formula. Watch. The area starts off with 1/2 again. So it's 1/2 D1. What do you think the D stands for? The diagonal times D2, and that's it. That's all there is to it. Let's we'll color these in so it kind of makes a little more sense. There we go. All right. That is the area of a kite. It's 1/2 times this diagonal times this diagonal right here. So if you know those lengths, if you know that whole entire length, and you know that pink length, and you know the yellow length, multiply them together, take half of it. Don't forget to take half of it. Even in my honors class, so many people forgot to put the half in front of it, even on the test. And they got it wrong. I just finished grading their test on this chapter, and several people missed a couple questions on the test because they forgot to put the half. They did everything else right, except they forgot to put the 1/2. Right? You got to know the formulas. Everybody got that? Now let me show you how they're gonna. Let me just scooch this stuff down. Let me show you how they're gonna label it in the book. Sometimes it gets a little confusing. But watch, this is what they're going to do. They'll put like a little line here, and then they're going to put a little line right here, and then they're going to do this and this. Alright? So that right there would be a diagonal. They'll probably give you a number or something. Okay? Everybody understand that? That's the pink one. Does that make sense? Because it's going from where? From this. See how it goes all the way to here? It goes from this point all the way across to this point. See how it's right below here? That's right there is the D1. So a lot of times they wouldn't put a D1 there because that could be a little confusing. Do you see why that could be confusing? Because you don't know if you're talking about from the end to this point or if you're talking about from the end all the way over. So they don't normally just put a number right here. If they did, it usually just means this part of it. Does that make sense? So that's why they put it outside and they put those lines. A lot of times they'll put arrows at the ends and they'll do like that. So how do you think they'll show the yellow one? Same way, but up and down, right? So it'll be like this, and it'll be about like that, and they'll have a line like so. Let's try and make that a little straighter. About like this, and about like this. And this would be what? If that's D1, this would be D2. Make sense? Alright, so when they give you those numbers, and they'll give you just regular numbers in there. Let's just make up one just off the top of our head, and we'll find the area of this thing. So this is 16. Alright, and this is, what do you think? It looks shorter, so yeah, let's just not go half. Actually, let's make these so we can do them in our head. I don't want to go 16. You can go 16. And you can go 8. I don't care. Let's go 8. Alright, so watch. How do I find the area of this? Area is 1/2 16 times what? 8. Alright? We can do this in our head. What's half of 16? 8 times 8 is? 64. So the area of that would be 64. Make sense? Pretty easy. Now look, sometimes, I'm not going to do an example because we just did one like this, but sometimes they'll give you the area, they'll give you one diagonal, and you got to find the other diagonal. Alright? That shouldn't be a big problem because we just did one like that with a trapezoid. Now what did I say? We're going to have two different shapes, but they have the what? What did I say about the formulas? Nobody remembers? They have the same formula. Okay? So this shape that I'm going to do right here, actually let's go find it. I got one already over here. And here's the shape right there. So let's copy that. You're absolutely right. It's a rhombus. And what do we know about a rhombus? It is a parallelogram. Very good. So why do I need another formula for it? Because I know the area of a parallelogram is just the base times the height. Right. Well, what if they don't tell me the base? And what if they don't tell me the height? And what if there's no way to figure it out? But what if they give me the diagonals? Then I can find the area of this thing.
You said the formula was D1 plus D2.
On the
thing you did 16 times 8.
I didn't say it was plus. I said on a trapezoid. You got to keep them straight. On a trapezoid, you add the two bases together. On a kite, I didn't say you add them. It's multiplied. It's not added. There's no plus in between there. Okay, it's multiplication. That's why I multiplied. Okay, so make sure that you get those straight because there could definitely be some confusion between that. All right. Oh, do I add? Do I subtract? Just make sure you remember how to do that. Now this is a rhombus. A rhombus means all four sides are equal. It means that look at this. It means that they are perpendicular, right? The diagonals are perpendicular on a rhombus. We learned that a long time ago. And there we go. So watch. We're gonna find the area of a rhombus. What did I say the formula was? It was just like area of a kite. Exactly right. It's the same exact formula. So let's write it down. It's 1/2 what? D1 times D2. Okay? So the area of a rhombus is 1/2 the diagonals. Okay? So this would be one diagonal, this would be another diagonal. Multiply them together, take half of it, and you got the area of that rhombus. Again, I'll repeat myself. In the other class, somebody said, well, I thought a rhombus was a parallelogram, and the area of a parallelogram is the base times the height. You're exactly right. But what if they don't give you the base? And what if there's no way to figure out what the height is? Then you'd be sunk. You couldn't use this, could you? All right, so, but what if they give you the diagonals? Then you've got something to use. right? So knowing the diagonals is going to be very difficult, maybe sometimes impossible to figure out what the base and the height would be. It would be possible. You still could do it probably, depending on the numbers. Yeah, if they give you this because we know it's bisect, I'm not going to go through that, but it'll make it really, really difficult. If they know the diagonals, you could still go base times height, but it would make it really difficult. Okay, but if they give you the diagonals, use this, and that makes it really, really simple. Okay, that's all we'll say about that. That's area of a rhombus. That's kind of nice, isn't it? You got two different figures with the same exact formula. So that's nice. So it's less that we have to remember. All right, I'm going to give you a worksheet, and it's over section 11.2. And that's going to be your homework for tonight. All right, so get that thing done. We'll go over it tomorrow.